Okay, let's get started on percentage composition. This starts on page 24 in your books. And it's all about the ratio of elements in a substance. So it could be a compound. For example, as it says in our booklet, if we consider aluminium oxide, what this is telling us is that within the crystal lattice, the aluminium ions to oxide ion ratio is 2 to 3. And so we can use this information to work out percentage composition, which is always by mass. So the question won't necessarily explicitly tell you that it's by mass, but it will be by mass because you're using relative atomic masses to work out the percent composition. Okay, so let's look then at the worked example on page 25, where we're asked to calculate the percent iron in iron oxide. Fe2O3. So we know then, again, it's the same as the aluminium oxide here, that these are in a 2 to 3 ratio within the crystal lattice. What we need to know is the atomic masses of each. So we're given in the question that the atomic mass of iron is 55.85. We also know now that what that also means is if I have a mole of iron atoms, it will have a mass of 55.85 grams. And our relative atomic mass of oxygen is 16.00. So we start out by calculating the molar mass of the iron oxide. Remember that the molar mass, we use the capital M for that. And with this information, it's going to be 2 times 55.85 plus 3 times 16 will give us 159.7 grams per mole. Dodgy 9. Good idea at this stage in your calculations to look at the number you've come up with and look back and see, does it make sense? And till it's 50, that's going to be around like 112 or whatever. So yeah, that's looking like it should be about right. It's good to double check your calculations as you go along. So we're interested in the iron part though, in the iron oxide. And so we want to find this, which will be 2 times 55.85, because there's 2 of them in every, if I have 1 mole of iron oxide, I'll have 2 moles of iron atoms, divided by this, the total. And because it's a percent, to make it a percent, we multiply by 100. Now, I didn't have to do this as a separate step if I didn't want to. I could do it all in one calculation if I want. That would be by just doing my iron up the top and this one down the bottom. Obviously the answers will be the same. So it depends on what you feel most comfortable with. If you want to calculate the molar mass first and then go on and look at your compound, or else you then that we get 69.9%. And that will be the same for either method. What can we infer from this about the percent of oxygen? If it's roughly 70% iron in the iron oxide, what does that mean about the oxygen?
They're a lot lighter than aluminium.
Or iron, yeah.
Oh, sorry.
Has a much lower mass. But that would tell me that I've got about 30% oxygen, because it's got to be the rest of it, doesn't it? Yeah, so I could also then calculate the percent oxygen by just saying 100 minus 69.9. If I had to calculate, because that's all there is in it. This is a pretty simple example because we have only got two elements making up the compound. But it's this part here that turns it into a percent. I do find that generally the specialised students have the most difficulty with percentages. So some of you are headed on that trajectory. You might also find it hard. The simpler the maths, the more confused. Inverse proportion. Okay, so there are some, try this yourself, questions to do. And there are also questions 31 to 34 on page 25. You can go on, once you finish the earlier ones,